Okay. Okay, last time we learned the distance formula. So I'll remind you right here. This is what we did on 7.2. Okay. So the first thing we're going to do is just review from 7.2. There's calculators over there if you need one. Daniel, perfect. Show everyone where the calculators are. Okay. So it says find the distance of the point. Okay, so this point right here at 3, 4 from the origin. That's our word for 0, 0. Okay. So to review last time's stuff, we'll have our origin be our start, and 3, 4 is our finish. And I want to find the distance between them, so the length of that line, if I could measure it, okay? Huh? Yeah, finish or final, and S is start, okay? So we'll do our distance equals the square root of x finish, so 3, minus x start, so 0, squared, plus y finish, 4, minus y start, 0. What's first? Good. So 3 minus 0 is just 3 squared. 4 minus 0 is 4 squared. Should I square those first or add them first? Good, because I do exponents next. Good. 9 plus 16. You can use calculators or a times table to help you. 25. Should I do a factor tree or is that one a perfect square? Yay. Okay, so that reviews last time stuff. So if anybody was gone last time and that made sense, awesome. You just made up the lesson. Okay. Any questions on last time stuff? Okay, if I was going to find other points on this graph that are also 5 away from 0, 0, are there any other points that are exactly the same distance away from 0, 0? Mason? Okay, flip it, right? You could mirror it. Okay. That's a good idea. Are there any other points? Yeah, I know, I heard. I'm going to say it in a second as soon as I get the other ones. What other ones could I do for 5 away? Or like, couldn't I go straight up, right? Okay. So Addie noticed a second ago, what shape are we making, Addie? Look at that. That is what we're doing today. We're going to use our distance formula. Oops, that circle's not good right there. We're going to use our distance formula to help us write equations of circles. Because here's why I can use the distance formula to write equations of circles. Can anyone raise their hand and remind me what the definition of a radius is? Anybody remember the definition of radius? Definition of a radius. Okay, then tell me what it is. It's like the halfway point in like that longest length. That's a good way to think about it. Good. Anyone think of another way to describe what the radius of a circle is? Radius. Okay, distance from the arc or the outside of the circle to what? Or the center. You guys with me? Okay. So one thing about a circle that's true, okay, is that the distance from any point on the edge of the circle to the center of the circle is always the same. That's what's making a circle, right? So on this one, those would all be 5. Does that make sense? Okay. Good. So far, so good, I think. I don't think you need to list 12. You guys seem to be getting the idea. Let's go to here. Take a second, and I want you to try just reviewing from last time, finding the distance between those 2 points on number 4. Okay? So I want you to review again from last time. I did one with you. Now I want you to do it on your own. Try number 4. Okay, try number 4. Try number 4. You'll do your left point as start and your Y point as finish. Okay? So this will be your start point. This will be your finish. So my X start is 1, my Y X finish is 4. So 4 minus 1 for 1. Okay, so remember from last time? Oh, that's okay. So here, so this is X finish minus X start. So this is my start point, this is my finish point. 4 minus 1. So that's the X. That makes sense? Okay. Jay, did you get this one finished?
Yeah.
Good job. You have in secondary 1 and modern math.
It was something different. I don't remember anything else.
Yeah, it was 1 and 2. Like X1 and Y1 and X2 and X2 probably. Yeah, it could be that. No. Oh my goodness, I got 5 again. That's just a coincidence that not every circle has a radius of 5. Okay, we're doing okay? Who else got 5? Anyone else get 5? Good job. Okay, so now we're going to apply this to circles, okay? So here's kind of what the idea is, okay? So it makes a circle. Okay, so that should say distance formula. Okay, so our distance formula from last time looked like this. I'm jumping ahead. So this is me just writing it again. Okay, so So let's talk about this. We're going to apply this to circles. Now, the reason why before I needed to differentiate the x finish and x start is because they were both x's. Does that make sense? Okay. So this time, right, Aiden, can you put your phone away? Okay. You can use a calculator up here if you need one. Okay. But this time when I'm dealing with circles, let's say I wanted to find all the points on this graph that were 5 around this center point here, okay? My starting point is going to be the same for every point on this circle. The center. Does that make sense? My starting point, if I was going to find the distance between of any of these lines of these radius lengths, my starting point, my x start and y start are going to be the center of that circle every time. Does that make sense? Okay. So we call the center of a circle, we call it HK. The other thing that's going to be the same for every point on the circle is this D, this distance. What's that going to be for every point on the circle? Go on. Don't overthink it. What's that distance D going to be for every point on the circle? 5 or radius. I would have taken 5 or radius, right? Because if I found the distance between these 2 points here and I got 5, isn't that what makes a circle? That distance of 5 would be the same all the way around.
But it's not going to be just 5. It's just the radius.
It's just the radius in general, right? Okay, so that distance is our radius. Okay?
The distance is the radius?
Mm-hmm. So here's what I have from last time. Almost like I'm making you guys write it a bunch to try and help you remember it. So that's the same as saying radius equals x minus h squared plus y minus k squared. So our distance is always the radius of the circle. And my x start is the same as my center.
So it's the same with different letters.
Yep, that's what I'm trying to point out to you.
What the frick?
Okay, that should be a good thing. You guys thought last time was so easy, right?
Okay, then why is this? Why are we learning this? This is weird.
So do you think after last time's lesson I could give you a worksheet on circles and you could have just done it automatically? Or did you need me to teach you how the letters are different?
Why are the circles necessary?
Well, because they just graph different types of functions. You know what a Doppler radar system is?
Yeah.
It's like a submarine or an airplane, right? There's certain types of movement that are only graphed by circles. But that's the whole point of me trying to point this out to you, that the formula for a circle is the same thing basically as the distance formula, right? We just know that our distance is our radius because that's the same for every point around the circle. And our starting point is always the same for any point on the circle because it's always the center. We doing okay? Okay, now the last thing is that usually when we do a circle formula, we don't like the square root there. Does anybody know how do I get rid of this square root? Anybody remember from last time? How do I get rid of that square root? Square it. If I squared that, this is our circle equation we're going to use the rest of class today. Oh, this third one was supposed to be that distance equals radius. Okay.